Hello learners, I'm Mr. Saul. It's a beautiful day today, so I decided we could do our lesson outside. Now, if you remember from the last lesson, we talked about physical properties and how we use those properties to describe the things we're talking about. So, what we're going to talk about today is what happens when we change those things, when something goes through a change. Now, if you remember from way back last semester, we talked about how any change requires energy. So, to do these changes, we'll be using some energy in different ways and different types of energy. But let's look at the two main types of changes that can happen. On the one side, we have physical changes, and on the other side, we have chemical changes. Now, physical, you might know this word like from physical education or PE, and that is things that happen that you can touch or feel or see. They are very obvious things. Some of the physical things that we can change about something would be size, its shape, its texture, or its state. And by state, I mean solid, liquid, or gas. So when these things change, I don't know if these seem familiar to you, but these are the different properties. So we can change the properties of something if it's a physical change, but nothing new will be created. We're not making anything new. Let me show you an example. So here I have a piece of paper. Let's put this through some of these physical changes. Can I change the size of this piece of paper? Well, sure, I can just give it a rip. Now I have two pieces of paper, but they're both smaller. However, did I create anything new? No, because it's still just paper. All I did was change one of its properties, the size. Still, nothing new was created. Can I change the shape of a piece of paper? We all know this is a rectangle. If I change its shape by, say, crumpling it up, now it's no longer a rectangle, but it's sort of a ball, right? Have I created anything new? Nope. Still just a piece of paper, now in a different shape. What about texture? Texture is the property that refers to how something feels. Is it rough or smooth? So let's use this log I have here as an example. As you can see, it's very rough, right? Lots of pieces coming off of it. This wouldn't feel good to really touch. But if I use my little planer here, my hand planer, this will take off all of those rough pieces. And in that area that I rubbed it, is now very smooth right there, okay? So this part is now smooth and this part is very rough. What I've done is I've changed the texture of this log, but did I create anything new? No, right? All I did was take some little pieces off and smooth it down. Those little pieces are now this sawdust that's everywhere, but nothing new was created. I only changed it physically. A physical change does not create anything new. It just changes its properties. Let's talk about states. As you guys know, there are three states, right? There's solid, liquid, and gas. So if I have something that's solid, like some ice here, I can turn this into a liquid. How? Well, by heating it up. And if I heat it up enough, by squeezing it with my warm hand, ooh, that's cold. You can see all this liquid dripping down, right? Well, that liquid is just water. So what would happen if I took that water and put it back in the freezer? I would get ice again, okay? So in this way, we can see I'm not actually creating anything new. Water, ice, and steam are all made out of the same thing, the water molecules. I've just changed their state. Are they solid, are they liquid, or are they gas? But really it's made out of the same stuff. Ice is nothing different than water except that it's in a solid state, okay? Now, let's talk a little bit about chemical changes. Chemical changes are very different because when something goes through a chemical change, it's going to create something new, something that we didn't have before. And I can't undo a chemical change the way I can undo a physical change, right? I could try to put my piece of paper back together, or I could try to put my little pieces of wood back onto the log that I took it off of. but it's still going to be made out of the same stuff. Paper will be paper, wood will be wood. When I'm going through a chemical change, things will be different, something new will be created, and I can't go back to what it was before. So if I take all the ingredients of a cake, the flour, the eggs, the oil, the butter, the salt, the sugar, all that stuff, put it together, mix it up, put it in the oven, and cook it, then when it comes out, it's going to be something new. It's going to have gone through a chemical change. And the energy for that chemical change came from the heat in the oven cooking it. But now that cake is not all of its separate ingredients anymore. Now it's a new thing that can't be unmade unless, well, no, it just can't be unmade. Okay? Next up, we have decay. Decay is when things rot and fall apart. So we see decay, especially during this time now, with all these leaves on the ground, right? The leaves that fell from the tree, they're dead and dying, and they are decaying. So I can crumple these leaves up and they'll just fall to the ground in lots of little pieces. I even grabbed here's another example. Here's a brand new fresh leaf that I just picked off of one of my plants. As you can see, it's nice and healthy and green and all that, right? Same plant, but here's this leaf. This leaf has gone through decay. It has started rotting and falling apart. So now I can take this leaf and crunch it up, and it's pretty much decayed and rotten. Can I turn that back into this? Definitely not, because it's gone through a chemical change. It has changed on a chemical level, and it can't be put back the way I can refreeze ice that has melted. This leaf turned into the decayed leaf through the chemical change of decay, of rot. And that's not something that can be reversed. Something new was made when this rotted, and that would have been the little tiny pieces that crumpled up. So decay is another chemical change, and nothing new or something new was created because this turned into something else. All right, next up we have burning. Burning is a very exciting one, but also very dangerous. So I have to tell you, do not play with fire at home. You have Mr. Saul to play with fire for you so that you can see. So let's take a look at what I have set up. We know that we have a bunch of leaves, right? So here's my fire pit, and I've filled it all the way up with leaves that we're going to be using for our experiment. All right, folks, like I said, do not do this at home. Fire is very dangerous and not something to play with. I am doing this for science so that we can see what kind of chemical change happens to these leaves when they get burned. So right now, these leaves are in the process of decaying. So they're already going through a chemical change. Let's do a different chemical change where we add in a lot of heat energy and see what happens. So I have my matches here. This is another chemical change, starting with the sulfur head of the match, and then when I strike it, it turns into a flame. Oh, that one went out. All right, so here we go. Remember, do not do this at home. So now we can see the chemical change that the fire is causing is starting to affect our leaves. And if we look closely down here, we can see that as the leaves burn, they turn black and they turn into ash. That is because they're going through that chemical change of the fire burning them. And what's left, this ash, is not something that we can turn back into a leaf. It is a new substance that was made from this chemical change of burning. You can also see here, a lot of smoke is coming up. Where's the smoke coming from? It's the little, whatever the leaf was made out of, those little leaf pieces are now getting heated up, and then a lot of them is rising up as smoke. So where's all the leaf parts going? Well, some of it turns into the black ash that we're so familiar with, and the rest of it floats away as smoke. But whatever it is, whether it's turning into the ash or the smoke, that's something new. It's not something that we can turn back into a leaf. It's not something we can turn back into a leaf very easily, right? So this is a chemical change. It's something new has been made by changing it, right? Okay, that's enough fire. So here we see some of those leaves that were burned up and are now black and crispy, and they're something new. They're not the same as when they were a leaf. Now they've turned into what we call ash. All right. Okay, so last one we're going to look at is rust. So rust, and this is something that's kind of dangerous, so I need you guys to be very careful with this, okay? Rust is something that happens to metal when it's been left out in air and water, and it goes through a chemical change where that metal ends up sticking to the air and water and changing in a way that it can't be changed back. Now the thing about rust is that this is my rusty chain. Can you see that pretty well? So this is my rusty chain. As you can see, it's covered in this sort of black brown iron dust, and if I touch it, it kind of gets all over my hands. Now this iron chain, it's not very dangerous to me because there's no sharp parts, so I can touch it pretty safely. It's kind of heavy, but other than that, it's not a big deal. When I first got this chain, it didn't look all brown and rusty like this. It was gray and shiny metal, right? But over time of being left outside for so long, the outer layer of metal rusted and created something new, which is that rust. So the dangerous thing about rust is this. Here I have a rusty nail. As you can see, it's all brown, covered in rust, and it's got that sharp tip. Now, if this sharp tip breaks the skin and gets into and this rust dust, this brown dust gets into your blood, it can be very, very bad. It can give you a disease called tetanus, which comes from the metal getting into your blood, and it can make you very, very sick. So if you ever get cut by a piece of metal that has any rust on it, this brown stuff on the outside, you have to go to the doctor and get your tetanus shot. Otherwise, it could make you very, very sick. So we always have to be careful when we're working with rusty metal, because if it cuts you, it can make you very sick. Because this rust is something new that is created when metal gets left outside in water and air. Lots and lots of metal rusts unless you protect it with paint or something like that. But again, you guys have to be very careful about stepping on a rusty nail or cutting your hand on it or something like that. Because like I said, if this rust gets inside your body, it can be very, very bad for you, okay? All right. So we've learned about the physical and chemical changes that can change a lot of the properties of stuff. We know that we can change physically, we can change the size, the shape, the texture, or even the state, solid, liquid, or gas of something. And as long as we haven't created anything new, then it's just a physical change, right? We can put it back together to the way it was. When I sanded that wood to make it smooth, all that wood is still here, but I just changed its shape. Now it's not part of a log anymore. Now it's just sawdust. When I took the ice and I melted it, I changed its state, but this water, I can refreeze it and turn it back into ice. Or I could put it out on the stove and boil it and turn it into steam, and then I could catch that steam and turn it back into water. So changing the state, solid, liquid, or gas of something doesn't create anything new. It just changes physically. Chemical changes create something totally new. All the ingredients of a cake go together, and it's now a cake. It's not flour and eggs and sugar and all that. It's just a cake now. Same thing with decay. When something rots and falls apart, if an animal dies and its body rots, it's creating something new. It's not an animal anymore. Now it's a rotting body, okay? And it can't go back to being an animal because it's going through that chemical change. And remember, chemical changes, we can't go back to the way it was. I can't take a cake and separate out the eggs and flour and sugar. Now it's just one new thing. Same thing when something is decaying, it's turned into something new, can't go back to the way it was. Burning something, Again, ash and smoke is what comes out of burning something, and I can't take a bunch of ash and a bunch of smoke and stick it back together and make a leaf. It just doesn't work like that. I could rip a leaf and that would change it physically, but if I burn it, that changes it chemically. And then finally, rusting. I can't unrust a nail. I could sand it and polish it and remove the rust, but that's still that new rust. It's not going to turn back into metal. Now it's rust and it's going to be rust forever, okay? And remember, these are very, very dangerous. Be sure not to step or cut yourself on anything that's rusty metal. Okay, so now I want you guys to take a moment and think about some things around your house that maybe go through some physical or chemical changes. Let's start out with physical changes. What is something that you could change the size, shape, texture, or state of and not create anything new? When you're done coming up with an example for one of those, try one about a chemical change. What's an example of something that changes and cannot be turned back and totally create something new? Like, for example, if I cook an egg, I crack the egg open, put it in my pan, once it cooks, it's going to be something new. It won't be that old egg anymore. All right, Doodle, say bye to everyone. Bye-bye. Bye-bye. Do a good job learning.